Right, so let's have a look at our reduction formulae. You did reductions in core maths, but now we're going to extend them to the reciprocal functions and have a look at some more co-ratios. Remember that reduction formulae are used to reduce an angle in the second, third, or fourth quadrant to an angle in the first quadrant. The sign of the function in the given quadrant must be taken into account. And we're going to use these reduction formulae when we simplify trig expressions and when we do proofs. Let's first have a look at our co-ratios in quadrant 1. Now remember that we're dealing with radians and not degrees. So you can go and recap that. I'll have a look at it just now again. Well, let's actually skip there now. You can have a look at this diagram, which just helps you to do your conversions. But we're going to work mainly with our 0, and then what it would have been our 90 degrees is pi over 2. What would have been our 180 degrees is pi. What would have been 270 is 3 pi over 2. And then what would have been 360 is 2 pi. So if we have a look at our co-ratios in quadrant 1, we got sine of pi over 2 minus theta is cos theta, etc. You can have a look at your other reductions that you already know from core maths. Now, all of our reductions also apply to our reciprocal functions, and they've got exactly the same signs as their originals. So you can have a look at those. What we are adding in now is in core maths, you only deal with sine and cos. Now we're going to deal with tan. So tan of pi over 2 minus theta is cot theta. So that's a new co-ratio that you're being introduced to, which also works the other way around. Cot pi over 2 minus theta is tan theta. Remember, we also have co-ratios in our second quadrant because we've got pi over 2, which would have been our 90, plus our acute angle theta. So we're dealing with sine, cos, and tan, but please take note of the signs. Remember your cast system. So let's just have a look here. CAST, where all our trig functions are positive in the first quadrant, sine of an angle is positive in the second quadrant, tan of an angle is positive in the third quadrant, and cos of an angle is positive in the fourth quadrant. So all of our other trig ratios are going to be negative. You've got to look at the original function. So if I've got sine of pi over 2 plus theta, sine is positive in that second quadrant, so I'm going to have positive cos theta. Remember your name change. And this follows through, now also incorporating our tan and our reciprocal functions. Also in quadrant 2, we've got what would have been our 180 minus, which is now our pi minus. No name change here because you're not dealing with co-functions. However, take into consideration the sign that if you see sine, it's going to be positive. If you see cosec, it's going to be positive. Moving into our third quadrant. Now, whereas in core maths you weren't dealing with co-ratios in this quadrant, you might get questions in AP that do deal with co-ratios using what would have been our 270 minus, but now is our, all the way down here, our 3 pi over 2 minus. And co-ratios have name changes in this quadrant just like they do in quadrant 1 and 2. Sine becomes cos, cos becomes sine, tan becomes cot. However, only tan is positive. So you look at the original function, and that's why tan of 3 pi over 2 minus theta is cot theta, positive cot theta. Right, also this quadrant is our pi plus theta, which previously would have been your 180 plus theta. Bearing in mind again that only tan is positive and also its reciprocal cot. Fourth quadrant, we've got our 270 plus, which now we're dealing with 3 pi over 2 plus, bearing in mind that only cos is going to be positive and it's reciprocal. Sec. Look at the original function. So you've got your co-ratios for 3 pi over 2 plus theta. Remember your name change. Also in this quadrant, it's our 360 minus quadrant, which we're now dealing with 2 pi minus theta. Can you look at those? And your negative angles in this quadrant. Remember, your negative angles are just an angle measured in a clockwise direction from the positive x-axis. That is why we land up in the fourth quadrant when we're measuring a negative acute angle. So I've got sine of negative theta is negative sine theta, but cos of negative theta is positive cos theta because I'm lying in that quadrant. Same goes for the rest of our trig ratios. But just bear in mind that these rules for the negative angles can apply to any angle, not necessarily just an acute angle. The rules still apply regardless what quadrant you're working in. And that's quite important to remember when you're simplifying. It helps you a lot. Okay, so make sure that you don't just learn these off by heart. Remember which quadrants you're working in, is there a name change or not, and then what is my acute angle that I'm working with. Going back here, you can use this diagram as just a summary for cast. You can also use it for your degrees, radians, conversions, just to give you an idea of where those radians sit, especially while you're still getting used to making this mind shift from degrees into radians.